My name is Janusz Furtak. I came from Warsaw, from University of Technology. Here is the agenda of my presentation. In the first step, I would like to present issues of securing of IoT networks. In the next step, I would like to present the concept of a key generation and renewal system. I would like to call it as KGR. The main element of my presentation is the protocol, which is the main element of the system. In the next step, I will present a laboratory step and experiment description. In the end, we'll give conclusions. What's the problem with IoT? Nowadays, number of nodes of IoT growing and growing. A lot of firms, consulting firms, say that in a few years we will be a billion new nodes. With these networks are two main problems. One is the growing, and the second one is the security, because a lot of nodes gets us a lot of information, a lot of data, but we don't know if the data is trustworthy. So, what is the problem? We can use cryptographic algorithms to protect the data, but we should get into consideration that the nodes, the devices, have limited capabilities in memory size, in processing power source, but usually these nodes use short-range wireless links. So, for protection of this data, the algorithms and solutions is now, for instance, maybe certification authority. But when we can use IoT sense of nodes, it is not possible or difficult to use these methods because of the limitation. The second problem is following. Sense of nodes, it is usually small device which works in unprotected environment and is vulnerable for unauthorized interaction. So any enemy can change configuration, hardware configuration and program configuration. So it is a problem. And the big challenge is to build trust structures for these networks and ensure secure distribution of cryptographic keys. Because we can use the cryptographic symmetric algorithms. So the problem rises how to distribute securely these keys. What is the contribution of my works here? I prepare secure data exchange protocol, which is a main element of KGR system. This protocol is used for distribution, the keys, for generation, and renewal. All mechanisms which use this cryptography is supported by hardware-based trusted platform model. This special electronic chip which supports this algorithm. Because in IoT systems, for distribution data, usually is used MQTT service. For this protocol, I use this service too, because to not be problems with communication. The presented protocol guarantees security regardless of the protection applied in MQTT service. So, using this protocol, we can use any MQTT service without any assumptions to security. Here it's a presentation how the system can work. Here it is an element which I know as a domain of sensors, because number of sensors is very big. Usually the sensors is grouped to the clusters of sensors. In each cluster can be prepared any procedures to secure data exchange. This element was my scientific experience from the 3 years ago. I prepared the solution to secure exchanging data in such network. So here in the slide there are 2 domains for IoT elements. The very big challenge for today is how to use non-protected data from IoT for IT systems with big requirements for security. So in each domain, working one node, which for the domain plays the role of sync node. So the all data generated in this domain going to this node. This node is an element which will exchange data with other elements of the system. So we should protect the exchange between nodes, which here is called as gateway, and for these nodes will be where key server and special node, which I name is authorization center. The schema of this system is like this. From point of view of my protocol, we don't see any domain and systems. We only see the nodes, which here is called as a gateway. Here, structure of my system will be like on the right side of the slide. The basic properties for the KGR system. KGR system is a source of symmetric keys only for authorized clients. The KS node will obtain data about authorized clients from authorization center. It's one of the nodes. MQTT service will be used. All sensitive data stored in the resources of each node will be protected with cryptographic algorithms, and transmission data will be protected too, cryptographically. Each N-type node must be prepared to work in the system. And MQTT module will support all these procedures. Because we are using MQTT service, this service works in the formula publisher-subscriber. What does it mean? One node, it will be source of data, should prepare the data and add to the data spatial string, which is named as a topic. For my systems, will be used 5 types of topics. When any node wants to get the data and should, in the first step, subscribe this subject, this topic, in the spatial node, which is named as a broker. So the transmission going is as follows. N1 for the source getting data, preparing data, using one of these topics, and send the data to broker. Each node which till now subscribed to any topics gets the data from the node. For this system, KGR, we have two phases. In the phase number 1, we prepare initialize KS node, AC node, and prepare credentials for other N nodes. In this step, N type nodes make a procedure registration in the system. After this preparing, we'll get to phase 2, in which we can generate and distribute the keys. How the data will be exchanged? I assume that all data transferred between nodes will be used encrypt them the NAC formula. What does it mean? The plain text, when we want to transfer it, in the first step, we should encrypt using one key. Encrypted text may be with any plain data, for instance, IP address and other. For this data is estimated hash function. For this one is used as second key. So for one transmission, we should get two keys. One for encryption, and second one for digital sign. What does it mean? In our system, KS server should generate in one round two keys for each node. The algorithm to exchanging the data and generating data is very simple. N1 node requests the keys for S50 and 2 and send this request to KS node. KS node generates these keys and temporarily store these keys in area of KS node. In the next step, KS node sends the keys to NY node and 2 node. After storing this data, N1 node send confirmation of the keys to KS node, and then confirmation is sent to N node. Here, the procedure is finishing. KS node removes the data from this memory. For this operation, this request and transmission, I prepare 6 types of frames. Now I don't want to present the elements of these fields because in the time is described in my paper. So here the diagram of this protocol is like here. Here is the first frame, yes, and the answers, and here. In the fields of the frames, there are keys NSK for encryption and NSSK sign for signing in each type. And here, topics which is randomly generated for one pair of open nodes. Because we using MQTT service, we should take into consideration the broker node and the topics 1, 0, and other. Here, the first element of this picture, it is a phase of preparing the KS node. The second element, it's an operation to register any nodes in the system. But the rest of the slide present the diagram how this service works. For instance, here node 1 publish frame and scale request with topic 1, and here is the answer, and it's advertised. For the system to test if it's work well, I prepare a laboratory stand which contains 4 Raspberry Pi nodes. Each node will use TPM module. I tested 2 types of these modules. Here is one example and the second one. From these 4 nodes, one is a broker, 2 nodes works as a N-type nodes, and 1 as a key server. Here I would like to present how it is work. The first elements of this 3 images, it is screenshots from N1 node. Here are the broker address and topics. Please, here the topic 1 is known for all nodes. It's the same, but the topic 2 it is known only for N-type node and KSL. When you want to request a new key, you should choose any function and choose my operator. For instance, here it is node with identity 222. Here it's exchanging the data. I don't think it is needed to describe. Here it is traffic on the MQTT server. For conclusions, I would like to present advantages of the protocol. The data exchange between components of the KGR system is cryptographically secure. Topics used for MQTT service is random generated too. The system supports this problem to distribute the topics between the nodes. All sensitive data on KGR system nodes are cryptographically secured. So when an enemy gets such node, it will be a problem how to get this data because it's cryptographically protected. In all nodes is used TPM module, and MQTT service broker is only plays the role as a medium. It is not participate in this protocol. So it is all what I would like to say. If you have any questions, I would like to answer. Thank you.
To see that there is research in terms of IoT security, because quite a few years ago, someone said that the letter S in IoT means security. And I would like to ask, do you have an idea how, since the IoT network is often used in the real-time regime, how much time your protocol adds to the typical data exchange scenario?
It is a very good question.
Oh, that's one.
Yes. We know that all procedures which want to use cryptography should have memory, power of calculation, and the time. It is a problem for these nodes because this device is limited. So I would like to prepare solution which can try to solve this problem.
Do you need to trust area?
Yeah.
between the small elements of IoT. Yes.
Yeah.
And we need put this elements, the main element of the system, on the gateway. Yeah.
Yeah. This element which will be responsible for exchanging data between domains of nodes and between the domains and our IT system.
Questions? I have one question more. Did you analyze how this system influences on the performance of communications between the elements?
From point of view on MQTT service, it's not a problem because the frames, its length of the frames is about 60 to 100 words. It is not a problem, but problem is with the procedure for cryptography. But the TPM module support this, and this is one of the solutions.
Thank you.